Alright, for our 8th grade lesson today, we're going to be talking some scientific notation. And once again, that's something we have been dealing with for a while now. Except for we are going to deal with the small numbers, also something we've seen before. But more importantly today is we're going to do some operations with those small numbers in scientific notation. And you'll see what that's about. We've done operations with the large numbers in scientific notation. But this gets a little different because we have negative exponents with our smaller numbers. Alright, so let's kind of take a look back and review some of the rules that we've had. So it says up here, in lesson 51 we practiced writing small numbers between 0 and 1. And we did that in scientific notation. In this lesson we will multiply and divide those numbers. Recall that to multiply powers of 10, we add the exponents, and to divide we subtract. Alright, so we had a rule saying that if we were multiplying and we had the same base, so 10 and 10 would be our base here. If we had the same base, we could just add our exponents together. So 10 to the 5th times 10 to the 3rd gave us 10 to the 8th. And if we don't remember why, you could write this out the long way. This means 10 times 10 times 10 times 10 times 10. So that's 10 to the 5th times 3 more 10s. 10, 10, 10. And how many 10s do you have total? You've got 1, 2, 3, 4, 5, 6, 7, 8. Alright? So the shortcut there was same base, you can add your exponents together. That is going to come in handy today. As will the other part, where we divide. 10 to the 5th divided by 10 to the 3rd. If we had the same base when dividing, we could subtract the top exponent and the bottom one, and that's where they get 10 to the 2nd from. 5 minus 3 is 2. And remember that, if we wrote that out longhand, 10 to the 5th, once again, is 10 times 10 times 10 times 10 times 10, all over 10 times 10 times 10. And everything's being multiplied on top, everything's being multiplied on bottom, which means we can start doing some canceling. And if we do that, this 10 and this 10, this 10 and this 10, and this 10 and this 10 can cancel out. And you're left with two 10s on top being multiplied. That is 10 to the 2nd power, which is 100. Alright, so that's why those things work out, just to review that. But like I said, we're going to deal with these small numbers today. So the laws of exponents implied on this previous page, or this previous example, they also apply to negative exponents. And we can exercise care adding and subtracting the exponents. It's kind of a weird sentence right there. Oh, it's alright. Basically all we need to know is that we can do the same things that we were doing up here with negative exponents. So I won't go through and show you the short or the longhand way, because now we know that that works. But remember, if we multiply, we can add our exponents. So now we can't forget when we're adding negatives or subtracting negatives. We can't forget those rules because they show up in many different applications, and this would be one of them. So we multiply, same base, we can add the exponents, so negative 5 plus negative 3 gets us to negative 8. Alright? We do 10 to the 5th times 10 to the negative 3. 5 plus negative 3 is 2, or you can think of it as 5 minus 3, same thing. Just a reminder, when you're adding two negatives, think about it as temperature. Let's say you're at negative 5 degrees, and then you're going to get colder 3 degrees. So if it's negative 5 and it's going to get 3 degrees colder, you're going to be at negative 8. And that's a good way to think about it. Or maybe if you are at positive 5 degrees and the temperature is going to drop down 3 degrees, you'll be at 2. Alright? So you can think about it like that. Now, when we are dividing, remember, we could subtract those exponents, and if they have the same base, which they do. So negative 5 minus a negative 3. That's one of these situations. negative 5 minus a negative 3. And we had we had a rule that if we were subtracting integers, these are integers, that we could turn it into addition. We could turn this into addition, but we had to do something to this. Remember, we could add the opposite of whatever the second number was. So, negative 5 plus the opposite of negative 3, which is a positive 3. So negative 5 plus 3 gives us negative 2 right there. So that's one of those rules we can't forget. Looks like over here it's going to be kind of the same deal. Here we have a 5 minus a negative 3. 5 minus negative 3. And that's kind of the same deal. Subtracting integers, we can add the opposite. So plus the opposite of this. The opposite of negative 3 again is positive 3. So 5 plus positive 3 gives you a positive 8. And that's where they get this 8 from. So those rules we cannot forget. And they will come in handy for us today. Alright, so a couple examples for us. This says if a sheet of notebook paper is 1/100th of a centimeter thick, how tall is a stack of 2,500 sheets of notebook paper? Express each number in scientific notation and perform the calculation in scientific notation. So not only do they want us to put these numbers in scientific notation, they want the answer in scientific notation. So we have to put 0.01 and 2,500 into scientific notation. So let's take a look at 0.01. Alright, we want to get that into scientific notation. Remember, scientific notation looks like something like this. We'll have one number to the left, decimal, possibly some numbers over here. We don't need to have that, but you'll see what that looks like in a second. And it's always times 10 to the something power. Alright? So we need it in that format, which means we need to move this decimal 2 spots over here so that we have 1.0. So 1, 2. So our decimal will be there now. And it is a small number. The decimal is to the left over here. We're going to have a negative exponent. So it's going to be times 10 to the negative 2. Because in order to get this back to this, we would take our decimal, move it 2 spots to the left. 1, 2. Remember, that's what that negative indicates for the negative exponent when multiplying by powers of 10. Alright? So that should be reviewed for us. So there's that number. These ones are a little easier, I would imagine. We like working with the bigger numbers better. So our decimal is currently right here, and we need to move it in between the 2 and the 5. So 2.5 times 10 to the something. So how many spots do we move it? 1, 2, 3. So this would be 10 to the third. Alright, so those are our 2 numbers. And we need to now use those to solve our problem. So how tall is a stack of 2,500 sheets if each one is a centimeter thick? Well, this is a multiplication problem. We're going to take the number of sheets that we have multiplied by how much, or the thickness of each one. Or if you want to do it the long way, add 0.01 2,500 times. And I don't think we want to do that. So let's just do it the multiplying way. And I'll show you what this looks like. And they want us to use these 2 numbers. So it's going to be, let's do 2.5 times 10 to the third times 1.0 times 10 to the negative 2. Alright, now what we can end up doing here, it looks looks kind of funky that way, is but it actually it makes things a little easier, and you'll see why in a second. Because they want the answer in scientific notation. What we could do, if we wanted just the answer, we could do 0.01 times 2500. But if they want the answer in scientific notation, this works out just fine. So remember, the commutative property of multiplication and addition says that we can rearrange the multiplication without changing our answer. So we can arrange our multiplication. Remember, the order can switch and we could still get the same answer. So let's do 2.5 times 1. And we'll do 10 to the third times 10 to the negative 2. So we've rearranged it, but now it's rearranged in a way that we can get our answer much easier. 2.5 times 1 is just 2.5 times 10 to the third times 10 to the negative 2. Alright, we are multiplying, our bases are the same, we can add these exponents. 3 plus negative 2 is 10 to the first. Or 3 plus negative 2 is 1, so that's where I get the 1 from. So our answer is, how tall is this? 2.5 times 10 to the first power in centimeters. If we went ahead and did this, this positive 1 tells me to move the decimal 1 time to the right. It'd be 25 centimeters tall. Alright? So there you go. And that's how they're going to have this. Well, you'll see in the power up, or not power up, the, what am I thinking of? The practice set, they're going to have a bunch of things that look like this. So what you want to do is rearrange each of these so that, or just like we did last time, so that it's easier. Notice we'll have 2 here where we're multiplying and 2 here where we're dividing. To save on time, I'm just going to go over 2 of each, or 1 of each, sorry. So let's do, well, C is a good one, and you'll see why. We'll do C first. Okay. So C is 4 times 10 to the negative 6 times 5 times 10 to the negative 4. So we want to put 4 times 5 together first. And we're going to put 10 to the negative 6 times 10 to the negative 4 together. And then that makes things a bit easier. 4 times 5 is 20 times 10 to the negative 6 times 10 to the negative 4. Alright, multiplying, so once again we can add those exponents. Negative 6 plus negative 4 is negative 10. So times 10 to negative 10. So it says we want to perform the calculation and express each result in scientific notation. So are we done? Almost. This one has one extra step. Our decimal is right here. Scientific notation tells us we only want one number to the left of our decimal. So we need to change this to 2.0 times 10, but it's going to change our exponent. So remember, negatives tell us that we're going to move to the left. So we actually moved it already 1 time to the left. So that's 1 less space that we have to go over to the left. So that's going to change this to a negative 9. So our answer would be 2.0 times 10 to the negative 9. And I'll see which other one we want to do here. Yeah, let's do, well, we could do D. Why not just do D? Alright, so we do want to be careful because here it looks like we're done and we were 1 step away from getting it into proper scientific notation. Letter D is a good one. This is 4 divided by 5, and then we could do 10 to the negative 8 divided by 10 to the negative 2. So let's do that. First thing we want to do here is 4 divided by 5. Not 5 divided by 4, but 4 divided by 5. We should get a decimal. How many 5s go into 4? The markers are not doing so hot right now. Let's see. 5 goes into 4 0 times. But 5 goes into 40 8 times evenly. Alright, so we're good there. So we know we're going to get 0.8 times 10 to the something. Let's write that down. 4 divided by 5 is 0.8 times 10. Alright, so now we have 10 to the negative 8 divided by 10 to the negative 2. So that means we can subtract our exponents because we have the same base. So negative 8 minus a negative 2. Let's look at that on the side here. Negative 8 minus a negative 2, we can turn it to addition like we did before. Negative 8 plus the opposite of negative 2, which is a positive 2. So now we have negative 8 plus 2, which is negative 6. Alright. But, once again, are we in scientific notation? No, because we're not going to count this 0 as scientific notation. We could just write 0 or 0.8 times 10 to the negative 6, but we want 8.0 times 10 to the negative 6. So, no, not to the negative 6, sorry, that's going to change. Alright, so it's going to be, we moved it one spot over. And that is the opposite direction that this is telling us to go. Because our negatives, remember we want to move those to the left. So we're going one more over against this, which means we're going to have to add on, make up for one going this way. So this will be the negative 7. Alright. So when we have to change it into proper scientific notation, it gets a little more confusing, and we got to think about it a little harder. And we'll definitely cover some of these tomorrow. So make sure you bring your questions on the assignment from today.